There are a number of different types of valves used in a water distribution system. They are all similar in that they provide a critical function for water providers. Valves control the flow of water, isolate water main breaks, reduce customer outage, and protect water from contamination. This segment of the Water Distribution Operator Training Series will discuss the installation and maintenance of water valves. Let's begin with a look at the main types of valves found in a water distribution system. Gate valves are a very common type of valve and are designed only to start or stop water flow. The gate, or disc, is raised or lowered by a screw, which is operated by a hand wheel or valve key. When fully open, the gates are pulled up into the bonnet, which provides almost unrestricted flow with very little head loss. When closed, the gates seat against two faces of the valve body. The main causes of a gate valve not seating tightly are when the faces become worn or when something lodges underneath the gate. Gate valves should not be used to throttle the flow of water for prolonged periods because vibration of the gates will eventually damage the valve. Gate valves used in water systems are either rising stem or non-rising stem, also called NRS. Rising stem valves are often called outside screw and yoke, or OS and Y, because they have an exposed screw extending above the bonnet. OS and Y valves are commonly used in pump stations and fire services where you can immediately tell whether the valve is open or shut by looking at the position of the screw. Outside screw and yoke valves can't be used where dirt might get into the screw, so all gate valves that are buried must be NRS valves. The screw on NRS valves threads down through the gate mechanism and the operating shaft is sealed at the top of the valve bonnet. Newer versions of gate valves use a resilient seat of rubber or synthetic material and operate more easily and have more positive shutoff than older valves. Newer valves have O-ring seals that require little maintenance. Most of the gate valves used in a distribution system are designed to isolate sections of the system. For example, a hydrant auxiliary valve is similar to other gate valves but has a special flange connection on one side to connect to a fire hydrant. Horizontal gate valves are like other gate valves, except they are designed to lie on their side, which helps in the case of large valves where it would be difficult to lift the weight of the gate. Horizontal valves are also used when a large diameter main is buried with little cover, and a vertical valve would extend above or too close to the surface. Valve connections used for distribution system gate valves include screw end for sizes up to 2 inches, flanged for exposed pumping station piping, and mechanical and push-type joints for buried water mains. A butterfly valve has a disc that is rotated on a shaft. When open, the disc is parallel with the flow. When closed, it is perpendicular to water flow and blocks water flow. Butterfly valves operate quickly and easily since the pressure on the two halves of the disc is relatively balanced and only 1/4 turn is necessary to open or shut them unless a gear reduction operator is installed. On the other hand, care must be taken not to close the valve too quickly and cause water hammer. Most distribution system butterfly valves are equipped with geared valve operators to make operating large butterfly valves easier and less risky. However, if the water main should ever have to be cleaned with pigs or swabbing, a butterfly valve would be a serious obstacle. Butterfly valves are primarily designed for on and off service. They can be used for occasional throttling, but if used for prolonged high-pressure throttling, the disc will eventually vibrate until it's damaged. Check valves are designed to allow the flow of water in only one direction. The most common use is on the discharge of pumps to prevent backflow when the pump is shut down. A foot valve is a special type of check valve installed at the bottom of a pump section so the pump will not lose its prime when the power is turned off. Depending on how and where a check valve is installed, when the valve slams shut, there is the potential for serious water hammer. Check valves are often equipped with devices such as weights, springs, and motorized drives to dampen the closing to minimize water hammer. Old check valves need to be periodically inspected for wear. If a worn valve on a pump discharge sticks in the open position, it could conceivably drain a whole water system backward through the pump. And if the valve should finally slam shut, the water hammer force could break piping and move the pump off its foundation. Pressure regulating and relief valves are designed to withstand the high pressure forces that are created when throttling the flow of water. It's generally desirable to maintain pressure to residences and businesses at less than 60 psi. Pressures above that are more likely to cause plumbing failures, leakage, and reduced life of appliances. A pressure-reducing valve has two upper operating chambers sealed from each other by a flexible reinforced diaphragm. The operating chambers receive pressure from the system and are adjusted to modulate the valve stem up and down to maintain the desired discharge pressure. The valve in the lower chamber constantly moves up and down to pass the correct quantity of water into the lower pressure system. Altitude valves are used to control or limit the level of water in distribution system reservoirs. They are similar in design to pressure-reducing valves and can be adjusted to allow water to fill a reservoir at a controlled rate and then close automatically when the reservoir is full. Altitude valves are also used to control flow to an elevated tank that could overflow under full system pressure. A double-acting valve restricts flow in both directions and automatically closes when the tank is full. A single-acting valve restricts flow into the tank, but unrestricted flow is allowed from the tank to the system. A pressure relief valve is used to protect a distribution system from excessive pressures. High pressure in a system can often be caused by water hammer. Common causes of water hammer include starting or stopping a large pump and opening or closing a valve or fire hydrant too quickly. Plumbing codes also require small pressure relief valves to be installed on water heaters and boilers to vent excessive pressure so the tank won't burst. A pressure relief valve is essentially just a globe valve with an adjustable spring to maintain pressure on the valve seat to keep the valve closed under normal pressure, and then open it when there's high pressure. Another type of relief valve is an air and vacuum relief valve. A float-operated valve allows air to escape when the float is down. When water enters the container, the air vent valve is closed. If a vacuum occurs, the relief valve allows air to enter the system. A common application of air relief valves is on the discharge of a well pump. It will vent air that has accumulated in the well column while the well is idle, so the air won't be blown into the distribution system. Backflow is the flow of any water, foreign liquids, gases, or other substances back into a potable water system. This cross-connection situation can be avoided by the use of backflow control devices. A reduced pressure zone backflow preventer, or RPZ, consists of two spring-loaded check valves with a pressure-regulated relief valve located between them. If there is a potential back siphonage situation, both check valves will close, and the space between them is open to atmospheric pressure. If there is back pressure in excess of the water main pressure, both check valves will close, and if there is any leakage in the second valve, it will be allowed to escape through the center relief valve. A double check valve backflow preventer is designed similarly to an RPZ, except there is no relief valve between the two checks. The protection is not as positive as an RPZ because of the possibility of the check valves leaking, so they are not recommended for use in situations where a health hazard may result from valve failure. And finally, there are two general types of vacuum breakers, atmospheric and pressure. Atmospheric vacuum breakers are often called anti-siphon valves, back siphonage preventers, or anti-siphon vacuum breakers. They are designed for intermittent use on piping connections where there will be no back pressure, such as toilet flush valves and lawn sprinkler systems. Atmospheric vacuum breakers must be installed beyond the last valve in the piping system. When the supply pipe is under pressure, the check valve closes against an upper seat to prevent leakage from the valve. When there is no pressure in the supply, the valve drops and allows air to enter the discharge pipe, thus preventing possible back siphonage. The pressure-type vacuum valve is similar, but is designed for use under pressure over long periods of time. Since they are operated frequently and are oftentimes quite large, many of the valves located in treatment plants and pumping stations are power-operated. On the other hand, since they are usually operated less frequently and may be smaller, most distribution system valves are manually operated. First, we'll look at the power-operated systems. An electric valve operator uses a small motor to rotate the valve stem through a gearbox. The motor is activated by a switch and is turned off by a limit switch when the valve is fully open or closed. Electric units can be set to intermediate positions for throttling flow. The disadvantage of electric units is that if there is a loss of power, either standby electric service or manual operating handwheels are necessary to continue using them. Hydraulic valve actuators are used in many treatment plants and pumping stations. They may be operated by either water pressure or hydraulic fluid. Their speed of operation can be controlled by throttling the flow of fluid to the cylinder. Pneumatic actuators are operated in a similar manner with compressed air. Now let's look at other distribution system valves. Small and medium-sized gate valves are generally direct drive. Larger valves require a geared operator, and so several turns of the valve key are required to make one turn of the valve stem. Operators should count and record the number of turns for each valve in the distribution system. That way, when valves are exercised, it's possible to determine when they are fully open and fully closed. Distribution system valves have a 2-inch square operating nut that is operated with a valve key. When a valve hasn't been operated for a number of years, it may be necessary to use a series of up and down motions to clear the stem threads and accumulation of corrosion on the gates. Close the valve about 5 to 10 turns, then open it 2 or 3 turns, repeating this until the valve is completely closed. If the valve doesn't seat fully on the first try, there may be foreign material accumulated in the depression at the bottom of the valve body. This sediment can be cleared by opening a downstream fire hydrant and then cycling the valve up and down from the closed position so the high-velocity water will scour it away. There are several types of portable electric and gasoline-powered tools used to operate valves. This will speed the work of exercising valves, but a power operator should have a torque limiting device to make sure excessive pressure is not applied to the valve stem. It's also recommended to manually apply the last few turns of travel in both opening and closing valves. Valve boxes are made in 2 or more pieces that are adjustable to the depth of the valve. The bottom of the box should be supported externally, so it doesn't rest on the valve. If the box was supported directly on the valve, the pounding of traffic on top of the box could damage the valve or piping. A valve vault is constructed around a valve after it is installed. Once again, it's important the bottom of the vault is on firm ground, so the vault won't sink and cause the weight of traffic to exert pressure on the water main at the points where the pipe goes through the vault walls. The neglect of valves results in inoperable, inaccessible, or lost valves that do not function in emergencies. A practical and proper valve program can result in improved reliability, reduction in customer outage, and lower maintenance expenses, as well as cost savings from reduced property damage or fire losses. The first step in developing an effective valve maintenance program is to establish priorities and identify critical valves to avoid large outages. Critical customers, high-volume users, and problem areas may need special attention. Here are some general guidelines for a valve inspection and maintenance program. Inspect each valve on a regular schedule, annually if possible. Inspect 16-inch or larger valves more frequently. Inspect the valve box or vault. Cycle all gate valves from full open to full close and back to open at least once every 2 years. Some valves require less exercise, so follow manufacturer's guidelines. Make any necessary repairs to valves immediately and maintain complete records of all operation and maintenance procedures. Distribution system valves are important to the operation of the system and are a critical component to deliver reliable service to customers.